Okay, so let's see. So now let's look at the array list. So what is the characteristics of array list? So if you have noticed, like what is the characteristic so far? So let's put all the characteristics one by one. Internally, array list using internally, it's dynamic. Okay, so it's dynamic. Internally, it uses array. Okay, it's non-synchronized. It's order collection. Okay, so it's maintain the order. It's index based, basically, you can say. On top of that, what we can say is here that default capacity is stand, then load factor is 0.75%. Then okay, so
we can save the same data type value in the array list, only same data type values.
It can have duplicate, right? That's what you're saying, right? It can contain duplicate.
No, I'm talking about if my array list is string, then it can only store just string values in that. I can't save the int value in that array list. So that can be the characteristic, right?
That's not the characteristic. That's the feature of collection. That's not the characteristic of array list.
Okay.
That's the feature of a collection. So we'll see like generics. Okay? That's called generics.
Okay.
Generics is one of the feature of the collection. Okay, so then here load factor 75, manipulations and search or retrieval, search or access. Okay, so there are two types of complexities. Okay, in this world. In this world means in the collection world. Space and time. Okay, so when you are basically adding or removing something from the collections, that here ON. So if you measure the, let's say water in liter, something is basically in kgs or lbs. So in this Java world, the complexity is in the collection world or the sorting or whatever. In this world, the complexity is basically measured in big O notation. Okay, so this is called big O notations. Okay, so don't worry about the space for now. Let's discuss about time complexity. So it's ON and search access is O1. Okay, so we'll little bit discuss on those topic right now. So let's say I have one array. Okay, let's say I have like say I define, let's say, integer number array, new integer 5, and then I want to add, let's say, sixth element in this one. How can I do that in the same array? If I want to add more than 5 elements in this array, how can I do that?
We have to change the size, means there is not any option.
How can you change the size of the array?
Like at the time of declaration.
But you already declare it and then you have to add it, right?
Yeah.
Do it.
We cannot shrink or expand.
Directly you cannot do it. So what is the indirect way? Because array is static. So see here, what I'm trying to explain, that array list is dynamic. Internally it is using array, so it's contradicting, right? Because array is static, right? Because once you initialize, you cannot change the size. But array list is dynamic, but still it is using array internally. Then how it is possible? These two statements are contradicting with each other.
We can create a new array and
Okay, so
copy all.
Yeah, so we are going to create, we can create, let's say, okay, so let's look at this way. Let's say we are going to create a new array. Okay, and then
capacity.
new integer, and then you put 6. Now what you're going to do? You add 5 first in this one.
Yeah.
And then add 6 one.
Yes.
Okay, now again you want to add 7th element. Then you again what you gonna do? You do this
Second.
new integer 7, and then 6 you copy again and add 7. So you are doing lots of ad hoc work, right? Because every time you add the element, what you are doing, you are creating a new array, adding the another element inside it, and then you add in the tail the next one, right? So this is basically a little bit time consuming. Agree? Okay. So how this guy is handling this one here? This is exact same way it is doing, but little bit in a professional way, little bit in a proper way. How? The initial capacity of the array is 10. Okay. And then load factor is 75%. So whenever this guy is reaches to 7, like capacity 7, okay. Whenever you are at the 7th element, it will increase the size from 10 to 16. When again 70% or 75% of 16, you count it. Okay, I'm not going to count it. You count it. Okay, and then if it reaches there, it will increase. So it is not increase one by one. It is increase in this order. So it does not require copy of every time. Okay, but internally it is using array only. So these two are covered now. Non-synchronized. We know what is synchronization in Java. The method in ArrayList, last time I told you guys, like there are methods, right? Add, remove, right? There are so many methods in the ArrayList. So all these methods are non-synchronized. Okay, so now we can think like if it is a non-synchronized, if multiple threads are accessing the ArrayList at the same time, then there will be a problem. We know if you have completed the threading, then you know that synchronization is the biggest problem, that multiple threads are trying to add or remove something from the ArrayList, then there might be a problem. Yes, but if that is not the case, then lock is an overhead. When you put synchronized, that means it's lock. It's an overhead. And that's the reason that array, because it is non-synchronized, it is faster. Because there is no unnecessary lock. But in order to achieve the synchronization, you have to handle it manually. Manually means explicitly. What does it mean? Either you use synchronized block when you have this kind of situation, or synchronized method. Okay, if you think that okay, somewhere in my code there is a possibility that multiple threads might access this particular thing at the same time, and then my at least might have some, I don't know what will be the eventual output, no consistency. In that case, you have to handle with the synchronization, explicit synchronization. Okay, and that's why Java is having these methods are non-synchronized. Can contain duplicate? We already see. If you are adding Ravi, Ajay, Ravi, Vijay, whatever, 2 times Ravi was there in the example, then output also coming 2 times Ravi. That means can contain duplicate. Order. It maintain the order. Same order. You see, like you add Ravi first, output in Ravi come first only, right? So maintains the order. Default capacity we see. Now big O notation. So now let's say here we need to learn a little bit mathematics. Probability. How many do you like probability? Okay, probability. Tell me what is probability? In maths we had probability, right? I think in the aptitude exam in MBA, right? In our MBA, whatever aptitude exam, even like whenever companies are coming for the campus interviews, they are asking for probability question, right? If I'm running 100 kilometer, 10 kilometers per hour, 100 kilometers away, how much time what is the probability that I will reach here on time? Anyways, so let's say if I'm staying, I'll tell you that I'm staying in this building. There are 100 apartments, and I don't tell you, okay, that in which apartment I'm living. Okay, so basically what happened, let's say, but I tell you, let's say I'm staying on, let's say, apartment number 101, or maybe let's say 10010. So you know that you are, what you're going to do, you are not going to start from number 1. Hey, open the door and you check, okay, is Pinkesh here? No. Like second, no, you're not going to do like this. What you're going to do, you'll directly reach to the
Number
10th
two.
floor, you directly come here, then you find me. So that's why access, you when you get out something from the array or array list, the probability is O1, complexity is O1. Then manipulation, let's just look at this example. Let's say I have some data Okay, let's say 20, 10, 30, 40, 50. If I remove this guy, 10, then what happens? This 30 will come here, 40 will go here, 50 will come here. It's jumping. If you add here, that's okay. But if you add in the middle, add or remove, so manipulation basically, right? Then there is shifting of element, because the characteristic of the array list is that it will maintain the order. You cannot basically leave this blank space. Once you remove something, that means you cannot say, okay, there is nothing in number one place. You cannot say like this. That means 30 will become 1. Okay, so this shifting happens. So how much shifting is happening here? 3 times basically. So the complexity here is ON. ON means O3. Worst scenario. If you add something here, no issue. If you remove something, that's 50. No movement is happened. O1, that's it. No movement is happening. So complexity is measured based on the worst scenario, not the happy scenario. Make sense? Okay. Any question here? All good? Okay. So now vector. See, in interview, people is not going to ask you that code. Okay, whatever I told you last time. This is the interview question. These all are interview questions. So vector. Difference between ArrayList and vector. What is the difference? Synchronized. All the methods in the vector are synchronized, and then this is legacy. And because it is synchronized, it's slower. Obviously, industry is using most of the ArrayList. Okay, so that's the internal structure, how internally that works. Now, linked list. All the characteristics are same. Only couple of characteristics. Internally, doubly linked list. So what is linked list? I already told you guys to create lots of program from Java programs. I told you last time that lots of collections were there, but no one has done that, I guess. And that one there are linked list also. So what is linked list? Okay, so address. So internally it is using doubly linked list. So linked list means it has an address. Okay, this is the element, and then there is a next address, previous address. This is doubly linked list. Then internally using doubly linked list, and then complexity is traversing complexity is O(n), reverse than array list, and manipulation is O1. Why is it so? Let's say I want to access 40, then you cannot directly reach to 40, even though you know that 40 is here. Even you cannot find out 40 is here, but you cannot directly reach to 40. How you are going to reach to 40? 10 to 20 to 30 to 40. You will go like this, and that's why access complexity is O(n). O(n) means this is 4, that means O4. If this one O3, O2, 1. Okay. Now manipulation. Let's say if I want to remove 20, then just change the pointer. That's it. No movement, no shifting.
Okay.
That means O1 manipulation. Okay, somebody ask you when to use ArrayList, when to use LinkedList. Okay, that's the interview question. So you have to tell the proper answer. Okay, so let me tell you. Okay, directly let me search. So whatever I'm explaining, this written here. Doubly linked list, internally array, manipulation array takes more time due to the internal implementation. We already understand what is internal implementation. Manipulation linked list takes less time compared to array list because in doubly linked list there is no concept of shifting. Okay, read it. If you don't read it, you won't understand, you won't remember, you won't be able to speak in the interview. Okay, so you have to read also, at the same time you have to create a program also. Now last thing is set, HashSet. In HashSet there are a few things. Okay, here I will come with the stack and queue in the end. Okay, so but let's complete HashSet first. HashSet, there are 3 items. Okay, so set, there are 3 items. Okay, HashSet, linked HashSet. Then again under the set, I should put like this. Okay, not like this. Then you have sorted set. This is interface. Okay, and then under this you have TreeSet. If you have remember the diagram, only one characteristic is different. It cannot, 2 characters cannot contain, no duplicate, basically contains duplicate, no duplication, and no order. Now comparison between ArrayList and set. ArrayList maintains the order, can contain duplicate, but set. So now if your requirement is that I don't want to have a duplicate, and it doesn't matter whether order is not there, HashSet here maintains the order. This is there. Okay, all set, no duplicate plus maintain the order. So now if you want to maintain the order, no duplicate, then you cannot use ArrayList. You have to go with LinkedHashSet. Okay, sorted set, TreeSet. If you add any value here, it will give you in order. But which order? Ascending or descending? What is ascending? 1 to 10. 10 to 1, descending. A to Z, ascending. Z to A,
Descending.
descending. Okay, so that's the order here. Okay, so it maintains the order when you add the value. So that's why you have lots of choices here. If you look at, you might ask yourself that, okay, what is the problem here? Like why we have lots of choices? Because all have different characteristics. Make sense? This page is with you. Okay, anytime you can refer this page. This page always you can open the whiteboard and you can refer it by yourself too. Okay, so that has set. Now stack. Last in, first out. And here there are method called push. Some value, you can put anything. Okay, put something, then pop. Pop does not get any value. Same like getter setter. Okay, getter method does not, you're passing set, you're passing something. Same like setter getter, push pop. If you pop out, you will get value here. Whatever you are putting inside. Okay, stack.pop. Okay, whatever stack you are creating, you get some value. That means, let's say if you stack work like this. Okay, so let's say you have values like this: 10, 20, 30, 40, 50, or some value, string value or integer, whatever. What happened? If you pop, this guy will come out. Again pop, this guy will come out. Again pop, this one. Then pop, this one. Then empty. Make sense?
Yeah.
Queue. See, I'm not going to create program. Okay, so don't expect that I'm going to create program for you. You have to do practice. Concept is important, but programming you have to do. Queue. FIFO, first in, first out. There are two types of queue, priority queue and Deque, everything. Just look at it. So now couple of questions. Okay, so let's say stack is very important. Okay, so let's say there are lots of interview questions people are asking. Let's say I'm just giving you something like this. Okay, I want to find out that this is the perfect or not. This parenthesis, perfect parenthesis or not. Because this is opening, this is closing, this is opening, this is perfect. Okay, but they might give you something. Let's say they don't give this, or maybe sometimes they don't give this in between. You have to tell whether this is perfect or not. Use the stack. Right, so we have to understand this, like how to use the stack here in array list. Okay, find out maximum number, minimum. Let's say we already understood this, right? So let's say we have array list. Okay, so let's say sort array. So in sorting there are so many algorithms, I already told you last time, right? But let's say if you in Java point Java program topic, there are sorting algorithms, bubble sort, read it. Okay, sorting and everything. There are so many types of sort. Let's say merge sort, quick sort, binary sort. There are
Linear.
so many sort, right? Insertion sort. Ultimately, what they're doing,
Ascending or descending.
ascending or descending. But there are so many flavors. Why? All has a different performance. All has a different complexities because of time and space complexity. This has O n square. Binary sort has O log 2n. Okay, this is log. In mathematics, what we have learned? Log base 10. What is the output for this one?
2.
Search on Google logarithm. Log 2,
2y.
log 10 base 2.
2, I guess.
Anybody else? I don't know. Search on Google. Tell me what is the answer. What is the formula? What is the formula, by the way? Let's say I want to put 2 here, right? Then this 10 will go here, or 2 something is formula, right? Who remember this? So let's say if I want to do like this, okay, log 2 n. You put something. So here, let's say 64. So what is n here? Find out n or some answer. We had this kind of solution problem, right? In mathematics, I do
Yeah.
remember. Okay, don't worry. Like you guys can use some brain. Okay, that's why I was telling you. But you have to basically use it. Okay, otherwise you will not think more. Okay, so complexities. Bubble sort O n square, time complexity O n square. Here heap sort O n log to n, and then they did not give you binary sort. If somebody has given binary sort, is there binary? No. Nobody likes binary sort. I think heap sort is no, not heap sort. Let me find out exactly. Binary sort search. Binary sort is not there. Is there? Right? I think heap is kind of binary. Let me compare. Let me make sure I have from my side also.
Yeah, second number.
Oh, it's search, right? But we need sort. Search is different, but sort. Oh, let me see this guy. Let me see heap sort. Heap sort here.
There is, I think, no binary sort. Binary search is only there.
Or binary insertion sort.
Yeah.
Binary insertion sort is there?
Yeah, but I can't say
No, I
it.
think heap sort is kind of binary, so it's divide and conquer. Yeah, binary insertion is there. So let me see heap
It's a
sort.
big of n for that. Oh, okay. Big of log of n.
Yeah, that's literally n into log. N is basically number of tree you are to. So basically it's a tree only. Heap sort is basically tree only. Yeah, this one. Right? Heap sort is basically kind of binary sort. So here you see like this one, right? So how this works. So you can look at it basically. How does it work? So here n log n, right? The complexity of this one, I think n log n. Efficiency, memory. They have given complexity here. They have given examples like this. How does it work? So how you can move up, down. So basically, there are ultimately different sorting algorithms, and then those all have different complexities, and that's why different sorting algorithms are there. So we need to know, okay, if you like write down the code and everything, because in collection itself we are going to see in the end there is sorting. Okay, so let's try a little more practice. So now let's go back to Java deployment again. And then so all this thing, so in ArrayList versus link, they have also given here all these things are covered. Now we are moving towards map. So you can see make sure that here everything is there, so you read it. Okay, whatever I was explaining is written here too somewhere, I guess. Yeah, here non-synchronized, all the characteristics. So all the methods are also here. Let's say add method is there, then index of contains. Okay, so the couple of methods are important. Okay, remove, okay, then at particular index also you can set the value. Okay, so size in array, basically we have length. Here there is a size method if you want to find out. You don't need to look at all the methods, but those are remove, add, okay, contains, index of, size. There are 6-7 methods are very important. And the characteristics. Okay, so here they have given non-generic and generic collection. You see, like non-generic and generic. That's not only that you can use only with the ArrayList. You can use with any collection. This generic. That's why I was saying that's not the characteristic of ArrayList. That's a characteristics of collection. Now map is not a collection. Why? Okay, who will prove it that map is not a collection? Why? From this diagram. I'm saying that map is not a collection. Prove it.
Map is not implementing collection interface.
Yep. So map is not implementing collection interface. That's when you say something is something, means Toyota is car. That means Toyota either implementing car interface or extending the car class. But here in hierarchy, there is no collection interface is implemented. Because if you see the collection hierarchy, collection was the interface. And that's why all these type, set and queue or whatever list, all are collection. So map does not implement or extend. That means is not a collection. But still, sometimes people are interchangeably use map is collection because we are storing some more than one value. But it's not a value only. What we are going to do here is map is key value pair. Okay, so let's see the example. Simple. Map has a put method, and then there are two things you are going to put. Map.put key and value. Map.put key and value. Put this key, these are the keys, and then these are the values. So in map, you are adding more than values like collection, but in a pair. Key value pair. Okay. So important part here is that how to iterate the map. Has map 5 ways to iterate the has map. Yeah, so they're given 5 ways here, right? So iterate the has map. So we are going to understand the internal structure. Okay, so like we'll come back here. Okay, so let's try to understand one more thing. Okay, first theoretically, and then we'll come here, like how basically we are iterating the hash map. So let's say I have one array, okay, and then I have some value. I want to store more than one value here. How can I do that? At 0th location of the array, I want to store more than one value. How can I do that? I want to store more than one value here in this array at the 0th location. Go ahead, Karthik, go ahead.
On same index, you wants to add
Yes.
multiple values.
Yeah.
The possibility, I don't think so. If you either you can concatenating the values in single one and
I don't want to
make
concate
it.
it. I don't want to concate it.
I don't think so. You have to goes on the next element for the next value.
There are ways. There are 3-4
Dot
ways. What, Bijal?
Dot add something.
But there is no add method in the array, right?
Yeah.
This is
Yeah.
not array list.
Add 0.
We already learned these guys. We are learning this one and you don't know. The topic itself we are learning right now. I'm giving hint
0
100%.
plus 1.
0 plus 1 means next index. You need to know, you don't need to play left side, okay? I'm giving you more hint. You need to play right side. Right side means value side.
If value.
Okay. Let's see. Solution number 1. If I'm create a class employee, and I put values f name, l name, salary, age. I create an object of this one. Employee is equal to new employee and give all this value. And then instead of this guy, I can put the object at this location, right? How many agree? How many of you agree that? Yeah, I'm showing more than one value, right?
I'm totally agree.
See,
If
if
you're
you
going
don't
to
understand object-oriented programming language, then it's not worth, guys. We don't understand. Oops.
You know what happened? You just confuse us with the double quote.
No, but you don't understand. This double quote is object, right?
Yeah.
It's an object. You have to come
You
out.
can.
Okay,
Even
now
though
let's
you
say
can also store
next.
an array list. You
Okay,
can also store
now
the
you are
array
coming.
list.
Now you are coming. Okay,
Yeah.
so now but now next solution. If I want to store, okay, so now here, okay, now imagine, let's say here you are going to not employee. Like in employee, imagine, let's say you have another class, any class, and you have key, value, and hash code. There are three value. Now I want to store more than one employee here. How can I do that? At the same location, I want to store more than one employee. That's where the Karthik has answer, right? So I can create an array list.
You can. Yeah.
Array list
Just store all the objects.
equal to something list is equal to new array list dot add e1, e2, e3. I can add a many, and I put this list here. So list has what? E1, e2, e3. So many objects, and that has many values, right?
Yeah.
Agree everyone or no?
Yes.
This one you have to tell the answer. Why? Because we learn everything. Okay, so now why I was saying that in HashMap, we have key value pair. So let's say when you are iterating HashMap, you are getting entry set. Entry set. Okay, so this is entry set. What entry set has? Key, value, and hash code. So while you are iterating, you will get the entry object. Okay, so you can get key and value out of this getter setter methods. No, yes. In employee, remember get salary, get name, set a getter method you created in this class. I'm explaining you internally how it works. So you can remember it. So this is the one of the way, right? How can you iterate the hash map? Because you are put is very simple. Okay, key value pair. It's okay. But when you are getting, you will get both, right? But at the time putting also, and that's what basically I was asking you this question. If I want to store more than one thing here, you cannot do that. So you have to have an object, and that's object is entry set, and that's what basically here while you are getting here map.entry.
Okay.
And then that has key and value both. What is the second way? If you're getting, you can do it this way. You get key set. You get all the keys, and out of those keys, you can get the value also directly, like direct all the values as well as direct only keys. So you can. This is the second way.
Okay.
Third way, if you have all the keys, you can map.get pass value key one by one, and then you get the value. If you have, let's say key set, okay, example, I don't know, think so they have given here. Yeah, this is entry set again. This is while loop, okay, so that's the same thing. Again, you are getting key value, and then here Java 8 for each method. Okay, if you completed list, then here also you can understand. If you're not completed list, you cannot understand this one, so you have to complete that. Then here you get the key set, and then you get all the key, and one by one get pass key here, and then you get the value. In map, you give the key in the get, and then it will give you the value of that against that key. Against that key, it will give you the value. Okay, so key value pair. So against is a key. So these all 5 ways are important. Why important? No need to mug up. Okay, you need to understand and remember it. So don't complain me that okay, sir, I'm not able to remember it. You have to remember by doing the examples and by understanding. Yesterday one student was asking, sir, I'm not able to remember this something all the collection type. I said you don't need to remember it. You have to experience it, and then automatically it will remember. Right? So if you have this chart, I told him like create a chart. Okay, so let's say here I found a chart. If I can get something in the history. This is yesterday, right? Yeah, this one. List, duplicate, yes. Order, yes. Position access, yes. Linked list, ArrayList example. Set, duplicates, no. Order depends on the implementation. What implementation? LinkedHashSet or TreeSet? It depends, right? Based on implement. So you have to create your chart, map, no duplicate keys.
No.
So in the map, if you see here has map. Okay, you see has map. These are all the characteristics. Okay, it doesn't maintain the order. Okay, so map maintains no order, non-synchronized. You have only one null key. If you are putting another null key, what happens? It will override the value. Okay, so see, all are very simple. If you remember it, load factor is 0.75 by default. Class default capacity is 16. Okay, so these all are very important for us to understand all the methods and then how to iterate. So now we need to understand the internal structure of the hash map. So now we already almost there. Okay, we already learned almost. So now let's again look at it. So let's say you have one hash map. You're going to do map dot put. So now we are going to learn a little bit about the. Now, if you remember in Java, in object class, we learn all the methods. Only 1 or 2 methods are remaining. Hash code is one of them. Hash code equals we only learn. Contract between hash code and equals. Then hash code collide. Okay, and then concurrent hash map also lock. Concurrent hash map. Okay, all these small points we're going to cover. So let's say you're going to do, let's say map dot put. Let's say you do XYZ, and then value is, let's say PQR. Map dot put. You can do, let's say EFG example, anything. Okay, so you can do any value I'm putting. Okay, so map dot put, I'm putting YXZ and then ABC. So now how does it work internally? So when you do put, okay, so in object class, there is a method called hash code. Here I just want to put hashing. Hashing is the algorithm. Hashing is the algorithm. And why we are using hashing, that we'll understand now. Let's say if you, first of all, what it will do, right? Hash code will return some number integer, okay? So there are some default implementation here, okay? Default. So let's imagine, if you remember, like while we are reading and writing a file, there was A to Z, okay? Let's say A to Z has 64 to 96. A to Z has something 97 to 122. Some values are assigned to the, each ASCII value is assigned, right? So now let's say it is giving you, let's say in internally, okay, so what is the default capacity of the hash map is 15, okay, that means internally it is using array, and then you have default capacity of that array is 16, okay, so 0 to 15 is 16, okay, so total. So I need to divide the values what you are going to put inside the map in this 16 basket, divide and conquer. So while you are getting the value, you are not looking everything. You are just looking one basket and then you get your value. Okay, so if you divide the values in proper way, okay, then in school what happened? Let's say if you, when we were studying, right, in college or school, you know, first year, second year, third year. So you know, like first year science, okay, this is the class, so you can find out. But let's say all the people are students are study together, it's very tough to find, right, for a particular person from the group of people, right? So now what we are going to do, let's say Java, what we do, let's see to find out the hash code. So let's say it will find out the hash code by adding the ASCII values. Example, I'm just giving, that's not the actual implementation, but let's imagine, let's say X plus Y plus Z. So let's say X has some value like 90, 90, 95, okay, 95, 67, okay, or 94, 94, 95, 96, 94, 95, 96, okay, so at least let's rough 180, 90, around 200 example. You divide by 15, okay, then you get, so you get 13 here, right? So 13 is your basket number, and then it will put your value X, Y, Z, okay, and then here hash code and whatever, okay, hash code is going to put. Now again, this value, it might find something else, some other hash code, basically EFG, okay, and then put some hash code here. Now for YXZ, it because Y plus X plus Z or X plus Y plus Z, mathematics again, same thing. So it will again get the same basket. Then that's called hash code collide. Then that, remember that page, I want to put more than one value at the same location. Then first what we have done, here key value pair, right? Here key value pair. So like here basically XYZ, and then is the key and value is PQR, and then hash code. So there are key two values, right? So this is object of entry dot map. But now I want to store more than one entry dot map object because hash code is same for two item. Then you have to use collection. But here internally what it is using? Linked list. So at this particular location, it is using linked list. Okay, so YXZ ABC. So this is linked list. Okay, so now let's see, when you do map.get, you pass the key YXZ because you need this value ABC. Then what Java will do? Again, it will go and find out the hash code. While you are putting the value YXZ, if it is giving you the value basket number 13, then while you are retrieving, hash code method should give you 13 only. Okay, if it is giving different, then there is a problem in your implementation. That means, what does it mean? Lost, value lost, right? Because you are putting in one basket, you don't know in which basket you put the value. Then while you're retrieving, you get the different hash code. That means your value is lost. While you are getting this one, first it will find out the hash code. Again, it will get bucket number 13. Then bucket number 13, what is stored? Linked list. So you will get the linked list. And again, what you're going to do with the linked list? You will start iterating. What is that inside? Objects of entry.map, same like employee object example. And then you will get key and value. So first object you will get the key and compare with this guy. Okay, using equals method. You will say, okay, XYZ, YXZ equal? No. Go to the next element. Okay, this is equal. Okay, yes, return ABC as the value. So you have to traverse only two elements because of the hashing. Otherwise, what you're going to do, you start from 0. Well, let's imagine, let's say hash code method is returning always 1, return 1. You override, because you can override a hash code method in your class, in employee class, or in whatever the class you are implementing, what type of object you are going to put inside the collection. You can override hash code method, same like equals and string, to string method. You return 1 always. Then what happened? Always all the values you are putting here. When you do map.get, what happened? It has to traverse everything.
Yeah.
If there are 10,000 elements here, it has to traverse, depends on the where your element it is. If it is your element is last, then you have to traverse 10,000 element. But if you are using proper hashing algorithm, then you don't need to traverse. You directly go to that bucket, minimum traversing. So your complexity is less. And that's the reason that what is the retrieval complexity? Here, everything is O1. Adding and retrieval complexity because of the hashing is O1. But provided your algorithm is well, it's not always O1 here, like retrieval, because it might be possible here you might get multiple values. Okay, depends. Right? So you have to explain in the interview like this. Yesterday only somebody asked this question. What is internal structure of the hash map? After Java 1.8, they have converted this linked list into binary tree. Why? To improve the performance. How binary tree improve the performance? Divide and conquer. If value is greater than 10,000 or 100,000, it is right side. So you are anyways removing the left side tree, right? So divide and conquer means tree. So your probability, it will increase the basically like performance. So that's the internal structure of the hash map. Any question here in the internal structure of the hash map? So let's go there. So hash map, working hash map here, they have given linked hash map. Linked hash map does not maintain the order. When you add the values, get the values out of the hash map, random, no order. But if you want to have an order by what? key. Order by what? Key. Then you can use linked hash map. Okay, linked hash map. Tree map, ascending, descending by key. Okay, so same like set, but here key value pair, but always, or you have only one criteria. Then has table, synchronized. Same difference between vector and array list. Here, hash map versus hash table. Hash map is non-synchronized. Hash table is synchronized. Hash table is legacy. Hash table is slower. Hash map is faster. Same thing. Okay, here everything is written. Here only difference is that hash table does not allow you null key. That's another difference here. That's different a little bit. But hash map allows null key, but hash table does not allow null key. Sometimes people might ask you this too. Okay, so this all about all the collections. Now we are dealing to manipulate the collection a little bit. Now we are moving towards manipulation of the collections. So now collection is an interface, but collections S is a class in Java. Same like executors is a class, and executor is a interface. So what is the use of this? There are all static methods. Let's see a couple of methods. We are mainly focused today on, like, after this in sorting. Okay, because sorting is very important, and then I will give you a couple of examples today, and then next time we'll complete the collection. But here you can see, like, when you add, let's say you are adding using list.add, you can add only one value at a time. But when you do collections.add all, and use the list, and you can add multiple values. Comma separated, you can give multiple values, you can add. So this is the utility methods. It will save your time. Okay, so collections.sort. That's what very basically, there are so many methods. Okay, collection.min, collections.max. There are so many utility methods are there, but insert. Collection is an interface. Collections is a class that is helping us to do some operations like manipulating of the data. We'll find out max number, min number, sort. Now we are going to focus on sort. Next is sorting. So as we know, in collection, you can put, let's say, string. Obviously, string, what is string? String is nothing but an object. Second thing is wrapper class object. You cannot put integer I equal to 1 and I you cannot put in the collection. But when put collection ArrayList.add 1, that means you are putting I capital integer wrapper class. If you remember, that was the use in the wrapper class, that if you want to store some numbers in the collection, you cannot use primitive. And that's why there is a wrapper class. That was the one of the uses of the wrapper class. And third one is user defined object. What does it mean? Employee, person, student, whatever the class is you are creating. If you want to create more than one employee and hold it in the collection, you can hold it. So there are three, these are the choices. Okay, first of all, we understand what are the choices to hold in the collection. Now I want to sort the data. So as long as you are putting the string, let's say you are putting string data. Okay, here let's say this you know, right, already, everyone. But I want to sort this one. Collection does not give you the sort, it maintains the insertion order. But I want to sort based on ascending, descending. Then you can do collections.sort and pass the array list. It will give you output sort by name ascending order. Okay, so collections.sort. Sort is a method. You can pass the array list. Okay, it's very easy for us to do the sorting. Okay, so this is strategy design pattern. Okay, here the collection.sort. So there are three types of design pattern: creational, behavior, and structural. Creation means with respect to creation of the object. Factory design pattern, abstract factory design pattern. Strategy design pattern is part of behavior because it deals with the behavior of an object. Behavior means it's not dealing with the object creation. Behavior, sorting is a behavior, right? Sorting is a behavior. So it's a behavior. Okay, so strategy design pattern. And structure means you are creating abstract class. And then child class, that's a structural design pattern. So collections.sort, okay, it's one of the design pattern, but it's helping us to sort the data. But same likewise, you want to sort the integer numbers, you can do it. But now problem comes when you are trying to sort the student. Okay, let's say if you are creating a student, okay, and then if you want to sort those data, let's say you have employee, let's say 100 employee, and you want to sort the employee objects based on their salary or based on their first name or last name. How can you do that? Okay, so if you if you do add, create an array list, add the employee, 10 employee, all have the different salary and age, and then try to put in the collections dot sort and see what happens. It will give you the compilation error. And there are, if you want to remove the compilation error, you have to implement comparable interface. Comparable interface is again compare to method. That's an abstract method. Okay, so we'll see this in detail. Okay, so now what we need to do now? Okay, so now let's create an example. Okay, first of all, has map. Okay, so we already see, like, just look over. Okay, whatever you have done so far, just create one collection dot sort example, simple, by just putting a string. Okay, so now let's take a little bit coding break. Okay, if you